Hello everyone. Good morning. I'm Shravani. Now I am going to have some classes on my YouTube channel, and this is my YouTube channel. All of you please subscribe my channel. Thank you for your support. And without doing any delay, today we are going to discuss chemistry. A topic, most important topic from chemistry. That is nothing but Mohs concept. This comes under physical chemistry. This is very useful when you go for inter and higher classes also. So just coming into the topic, moles concept. First, before going into moles concept, you should know about two concepts, that is relative atomic mass and also relative formula mass. Along with them, we will discuss the moles concept. See here, today, first relative atomic mass. Relative atomic mass, just a minute, I will open my whiteboard. Just generally, when we take elements are nothing but hydrogen, helium, lithium, beryllium, like that. So when we take elements, one element will be having one or more than naturally occurring forms. That is nothing but isotopes. Same atomic number, but atomic mass will be different. So mm, yeah, it is working. So see here. See here, these are the examples. For example, if we take chlorine, chlorine is having 35 mass number and its abundance value is 75%. And some chlorines may have 37 atomic mass number and its abundance will be 25%. This is nothing but the difference in the percentage of the isotopes. For that reason only we need to calculate the relative atomic mass. For example, if we take chlorine, chlorine general atomic number is 17 and some chlorines will exist in the mass number 35, means yeah, and some chlorines will exist in the mass number 37. So this percentage 25% means least, 25% abundance means naturally occurring, and this chlorine will be 75%. So when we if we take the 35, that will be different, and if we take only 37, that will be not accurate. So for that reason only we will calculate the atomic mass, relative atomic mass. See here, relative atomic mass. When we so for this what we do is just we do the average. See here, first relative atomic mass. Relative atomic mass is the weighted average mass of an element's naturally occurring isotopes. Means whatever the isotopes we are having, we just have to average all the mass of them. So calculate the element's relative atomic mass. You multiply the mass of each of its isotopes by its natural abundance percentage. Then sum these values and divide by 100 to find an weighted average. Yeah. Just what you should do is you have to multiply each element's relative atom to calculate relative atomic mass. You have to multiply the mass of each of its components times abundance percentage, means how much it is occurring. See here, for chlorine, 35 mass number 75%. So 35 into 75 you have to do. And 35, 37 into 25 because 27%. So then we have to add them together and we have to divide that by 100. See here, we will do it. 35. Just what you have to do, the formula is the formula I have mentioned here. See, sigma of means the sum of isotopic mass times abundance percentage over 100. So 35 atomic mass, 35 times 75. This one plus 37 times 25. 25. over 100 means divided by 100. So then you will get total will be 26. I think I have already done this. 2625 plus 925. 2625 plus 925 over 100. This will be equals to 10, 5, 15, 3, 35.50. So relative atomic mass of this chlorine will be 35.5. We will take general average. Do you understand all of you? See, this is what. Relative atomic mass is needed because actual atomic mass are too small to work with. And by comparing them to standard from carbon 12, we make these chemistry calculations simple and practical. For this reason, we need relative atomic masses. Next, in addition to relative atomic mass, we should also know about the relative formula mass. Relative formula mass is nothing but it is a sum of the relative atomic masses. Means if generally we will calculate this relative formula mass for compounds. Relative atomic mass will be for elements. Elements means only one element will be there, but in case of compounds we will be having one or more elements. So for that reason we need to sum up all the relative atomic masses of the elements present in that compound. See here, it represents the mass of one formula unit, molecule or ionic compound relative to the mass of the carbon 12 atom, which is assigned by the value exactly 12. See here, suppose if we take H2SO4, H2SO4 relative atomic mass of hydrogen will be 1, and 1 into 2 you have to do 1 into 2, and sulfur will be 32. Just one sulfur we are having, so 32, and oxygens we are having 4 oxygens, so 16 into 4. So it will be equals to 2 plus 32 plus 64, we will get 98. This is the, here we have the relative atomic masses. We just need to calculate the relative formula masses, and atomic mass will be represented by AR like this, and relative formula mass will be represented by MR like this. I hope all of you understand. Next, the main concept, moles concept. See here, moles concept. The mole concept is a fundamental principle used to count a vast number of chemical entities like atoms, molecules, or ions. In simple terms, one mole of any substance contains a fixed number of particles equal to Avogadro's number. Avogadro number is nothing but 6.022 into 10 power 23. See here, this moles concept will be used to count the vast number of chemical entities like atoms, molecules, everything. For example, when we take fruits, we will take 1 dozen, 2 dozen, like that. 1 dozen equal to 12 units. Like that, in moles concept, 1 mole equals to 6.022 into 10 power 23 entities. See, the formula for calculating number of moles is number of moles equal to moles times molecular mass, molecular weight, that is. Next, alternatively, you can express it as number of moles, that is equals to mass times relative formula mass. See here, we are having worked examples. For find the number of moles of 16 grams. To find the relative atomic relative, oh, just a minute. Just you have to do weight over relative formula mass. See here, for example, if we take oxygen O2, Its relative formula mass is 16. Relative atomic mass is 16 and its formula mass is 32. And we are having 16 grams of oxygen. So mass is 16. Mass equals to 16. Relative formula mass MR equals to 32. So what we have to do, mass over relative formula mass. Mass over MR. So it will be 16 over 32. We will get 0.5. 0.5. This is what. See here. Find the moles, number of moles of oxygen. N equals to 16 over 32, that is 0.5 moles. Similarly for H2SO4. H2SO4 molecular mass will be 98 grams per mole. So this will be 19.6 grams. So 19.6 over 98, you will get 0.2. Here mass is having grams and this is having gram per mole. This gram and gram will get cancelled and this mole from denominator will go to the up. So we will get 0.20 moles. Like that for calcium carbonate, CaCO3, 0.1 mole. Here they have given the number of moles, we need to find the mass. So what you have to do, number of moles times formula mass. Formula mass is 100 gram per mole. 100 gram per mole times 0.1 mole, you will get 10 grams. Like that, whenever they have given the atomic mass, we can find the atomic mass, we will know the relative formula mass. And whenever they have given mass, we have to calculate the moles. Whenever they have given the moles, we just can calculate the atomic masses. This is about today, relative atomic mass, relative formula mass, and in the next class we will discuss the other topic. Hope you understand. If you are having any doubts, just comment me. I will do any video or I will give explanation in the comment box.